Hello everyone, introduce you from group 11. The material that we will present is similar polygons and proving triangles similar. Before entering the material, let's introduce the members of group 11. The first is Humaira as the first speaker, Putri Ratu Adi Larigau as the second speaker, and Maulidia Ananda Nasrul as the third speaker. Just go ahead and we enter material. And for the first speaker, we invite.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you for the opportunity. My name is Humaira. Now, I will explain about similar polygon. Similarity is a shape where the angle corresponds to the same magnitude, and also the length of the sides of the corners also correspond by having an equal ratio. In other words, congruence is two shapes that have the same angle and side length. Likeness is generally denoted by using the notation symbol is that. Shape above is two similar shapes with several properties as below. Is compatible, side pairs have the same comparison of value. Here's the explanation. AD and KN sides are AD over KN is equal 36 is equal a half. The sides AB and KL are AB over KL is equal to 36 is equal to a half. The BC and LM sides are BC over LM is equal to 36 is equal to a half. And the CD and MN sides are CD over MN is equal to 36 is equal a half. So, from the description above, we can conclude that AD over KN is equal AB over KL is equal BC over LM is equal CD over MN. Next, angles that correspond to the same, namely, angle A is equal to angle K, angle B is equal to angle L, angle C is equal to angle M, and angle D is equal to angle N. The following are forms of similar polygons. Two similar shapes. Properties owned, the corresponding pairs of sides have the same length ratio. The length of the corresponding angle. Two similar triangles. Properties owned, the length of the corresponding sides have the same length ratio. The corresponding angles are equal. And the last, the corresponding angle have the same ratio, so that the angle sandwich of both sides have the same magnitude. And similar special triangle. A right triangle has the property that one of its angles has a magnitude of 19 degrees. An isosceles triangle has two sides of the same length. The two angles are the same and has only one axis of symmetry. An equilateral angle has the same length of three sides, three equal angles, and has three axes of symmetry. Now, for example, look at the picture below. The question is, RS is, and the answer, from the problem it can be seen that the trapezoid PQRS is proportional to the trapezoid ABCD. So it applies PQ over AB is equal to SR over CD. We can substitute the value 9 over 27 equal as SR over 6. By doing cross multiplication, generate 27 SR equal 54, and if each side is divided by 27, we will produce SR is equal to 2, then the length of SR is 2 centimeter. That's my presentation. Next, I leave it to my friend.
Okay, thank you. I am Putri Ratu Adela Rigau as the second speaker. Will explain the material about proving triangles similar. Because of the difficulty of establishing proportional sides, our definition of similar polygons, and therefore of similar triangles, is almost impossible to use as a method of proof. Fortunately, some easier methods are available for proving triangles similar. If two triangles are carefully sketched or constructed so that their angles are congruent, they will appear to be similar, as shown in figure 5.11. If the three angles of one triangle are congruent to the three angles of a second triangle, then the triangles are similar AAA. Corollary 5.3.1. If two angles of one triangle are congruent to the two angles of another triangle, then the triangles are similar AA. Rather than use AAA to prove triangles similar, we will use AA instead because it requires fewer steps. Example 1 can be seen in figure 5.12. Provide a two-column proof of the following problem. Given AB is parallel DE in figure 5.12. Prove triangle ABC is similar triangle EDC. The proof. Statement 1. AB is parallel DE. The reason is given. Statement 2. Angle A congruent angle E. The reason is if two parallel lines are cut by a transversal, the alternate interior angles are congruent. Statement 3. Angle 1 congruent angle 2. The reason is vertical angles are congruent. The last, statement 4. Triangle ABC is similar triangle EDC. The reason is AA. Strategy for proof. Proving that two triangles are similar. General rule. Although there will be three methods of proof, AA, SAS, and SSS, for similar triangles, we use AA whenever possible. This leads to a more efficient proof. Illustration. See lines 1 and 2 in the proof of example 2. Notice that line 3 follows by the reason AA. CSSTP its corresponding sides of similar triangles are proportional, and CASTC its corresponding angles of similar triangles are congruent. Okay, I think it's up to hear what I explain. Then the proven triangle similar material will be continued by my colleague.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for giving me opportunity. I'm Molidia Ananda Nasrul. I want to continue the previous explanation from Putri Ratu Adil. Now, in here, I want to explain to you all about proving a proportion. Strategy for proving a proportion. General rule. First, prove that triangle are similar. Then apply CSHTP illustration. We can look at the statement 3 and 4 of the example 2. We can look at the figure 5.13 that we want to prove that statements. Statement 1. Angle ADE is congruent with angle B. That reason is a given. Statement 2. Angle A is congruent with angle A. That reason is a identity. Statement 3. Triangle ADE is similar with triangle ABC. That reason is AA. And the number 4 or the last statement is DE over BC is equal to AE over AC. The reason is CSHTP. And then we continue the theorem 5.3.2. The length of the corresponding altitudes of similar triangles have the same ratio as the length of any pair of corresponding sides. And then here we can get the strategy for proving product of lengths equal. General rule. First, prove that two triangles are similar, and then form a proportion involving the length of corresponding sides. Finally, apply the means extremes property. Illustration. See the following proof and example 3. An alternative form of the proof. Theorem 5.3.3. If an angle of one triangle is congruent to an angle of a second triangle and the pairs of sides including the angle are proportional, then the triangles are similar. We can look at the figure 5.14. We want to prove we have a 5 statement. We want to prove and what the reason. The statement 1 is angle M is congruent with angle Q. That a reason is given or the given are hypothesis. And statement 2, angle 1 is congruent angle 2. That means that reason is that vertical angles are congruent. And the statement 3, the triangle MPN is similar with triangle QPR. That means the reason is AA. And number 4, NP over RP is equal to MN over QR. That means, or the reason is CSSTP. And number 5, NP times QR is equal to RP times MN. That means extremes property. Thank you very much for watching, and thank you very much your kind attention. Assalamualaikum warahmatullahi wabarakatuh.